Welcome back to B Spice. In this session, we'll focus on instrumentation, question and answers, part A, wherein we'll cover all type of flow measurement. Very, very interesting and important questions, tricky questions rather, right, friends? So, hope you had watched my earliest session on this question and answer subject, wherein we covered pressure, differential pressure, level, and hard protocol, and many more. See, this is limited to question and answers. Of course, we had uploaded around 200 plus videos on instrumentation detail engineering. Detail engineering in the sense of whatever you guys are doing in an engineering company. So all those have been uploaded in detail. If you're interested and wanted to learn instrumentation and control aspect, you can become a member and yeah, get benefited. Okay. So with that note, I'll move on to the questions. It's very interesting, in fact, all these questions. So flow measurement, what is that definition? See, as we all know, flow rate is defined as the amount of fluid that flows through a given area per unit, okay? And measured in units of volume per unit time, such as gallons per minute or cubic meter per second. So basically, it's defined as an amount of liquid flows through a given area per unit, right? Good. So, you know, there is a concept called mass flow rate and volumetric flow rate, right? Okay. Mass flow rate is a measure of amount of mass that flows through a given area per unit time. Okay. So it's a measure of amount of mass that flows through a given area per unit time. Why? Volumetric flow is a measure of amount of volume that flows through a given area per unit time. So this is a basic definition. Okay, let's get into more detail. Okay, mass flow is independent of fluid density. Very important. See, mass flow is independent of fluid density, whereas volumetric depends on fluid density. Okay, with this basic understanding, now I'll take you through few more in a simple way. Mass flow measures the number of molecules in a flowing gas. Number of molecules in a flowing gas. The number of molecules. Just remember. Volume flow refers the measures the space occupied by those molecules. So that's a basic difference. So mass flow measures the number of molecules. Volume flow measures the space occupied by those molecules. You got it? Yes, that's it. So volume flow is affected by changes in pressure, temperature, while mass flow is not. Okay. So mass flow is quantified in units like kilogram per second, gram per minute, while volumetric flow is quantified in units like liter per minute, cubic meter per second. Okay. I hope you got this understanding of mass flow and volumetric flow. Okay. So now few more. Principle of turbine flow meter. Of course, we have covered in detail, but I'm just giving a short notes. In a turbine flow meter, the turbine with multiple blades is placed in the path of a fluid flow. Very simple. Okay. The blades are designed to rotate in response to the fluid flow. Okay. The blades are designed to rotate as the fluid, falls on the blade, it starts to rotate. And the frequency of rotation is proportional to the flow rate. Very simple. The frequency of the rotation is proportional to the flow rate. That is about the turbine. Okay. What is the principle based in the fluid? What is the, which flow measurement is based on the principle of fluid displacement? As you can see, yeah, yes. So positive displacement flow meter measure the fluid flow by dividing the fluid into fixed known volume and counting the number of times these volumes are displaced to measure the flow rate. Very simple. So positive displacement flow. Measure flow by dividing the fluid into fixed known volumes. I think it's a typo error. Known volume and counting the number of times these volumes are displaced to measure the flow rate. That's it. Okay. Then one terminology, this is a twisted question. Okay. See, ratio of actual flow rate to the maximum rated flow rate of a flow meter. What is this? Have you heard about this? Ratio of actual flow rate to the maximum rated flow rate? Yes. So it is nothing but turn on ratio. So turn down ratio is the ratio of the actual flow rate to the maximum flow rate of the flow meter, and it's an important factor we need to consider when selecting the flow meter because it indicates the range over which the meter can accurately measure flow. That is very important. So it's nothing but the ratio of a turn-down ratio is the ratio of the actual flow rate to the maximum flow rate. Okay, very, very important factor. Okay, few more. Which flow meter technology is based on principle of measuring velocity of fluid at one or more points in a pipe? Any guess? Yes, it is ultrasonic. So ultrasonic flow meter use sound waves to measure the velocity of fluid at one or more points in a pipe. Ultrasonic flow meter. So by measuring the time it takes for the sound waves to travel upstream or downstream, the flow rate can be calculated. Right? Good. So second, one more. Flow measurement technique based on measuring the pressure drop across flow obstruction. Of course, everybody knows this. This is differential pressure. Okay. Differential pressure flow meter work by measuring the pressure drop across the flow obstruction. So it could be an orifice plate or could be a venturi tube or a flow nozzle. Okay. These are the differential pressure. Okay. Right. So by measuring the pressure difference between 2 points in a pipeline, upstream and downstream, the flow rate can be calculated. That's it. Then you want to add on, which flow measurement device is used to measure flow of viscosity, high viscosity. When you think about high viscosity, think about positive displacement. So positive displacement flow meter are ideal for measuring flow of high viscosity. Such as oil or syrup or honey, all these. Okay. Okay. Then, which flow measurement device is suitable for corrosive fluids? Any guess? Yes. Magnetic flow meters are suitable for measuring flow rate of corrosive fluids. Okay. Right. Which flow measurement use Faraday's law of electromagnetic induction? Again, magnetic flow meter uses Faraday's laws of electromagnetic induction to measure the flow rate of conductive fluids. Which flow measurement device is suitable for flow rate of dirty fluids? So turbine flow meters are suitable for measuring flow rate dirty fluids as there's no moving part that can be clogged. As there is no moving part that can be clogged. Okay, good. Now, which measurement and measure both flow rate and fluid density? Very important. Any guess? Yes, it is Coriolis. So Coriolis can measure both the flow rate and the fluid density, making them ideal for application where both parameters are important. Yes. So which flow meter uses the principle of rotating paddle? So this is very simple. Paddle wheel flow meter operates based on the principle of rotating paddle or wheel that is placed perpendicular to the fluid direction. So as a fluid passes the pipe, the paddle is rotated and the speed of rotation is proportional to the flow rate, similar to what we have seen in turbine. Yes. So the sensor attached to the paddle detects the rotation and provides an output signal proportional to the flow rate. That's it. Now, few more. Which flow measurement device is suitable for measuring flow rate of gas streams? Very, very important. Gas streams are more suitable for measuring flow rate of gas streams. So thermal flow meter. Yes, are more suitable for measuring flow rate of gas stream. Whenever there is a gas stream, always think about this thermal. So basically, it works on a principle that the rate of heat transfer from a heated element to the fluid, flowing fluid is proportional to the mass flow rate. That's it. So it works on a principle that rate of heat transfer from a heated element to the flowing fluid is proportional to the mass flow rate. So the heated element can be a thermistor or TD or a thin film heater. Okay. So another point. Okay. Now we have talked about the gas stream. So what is about the liquid? Yes. Positive displacement, Coriolis and ultrasonic. That are better suited for measuring flow rate of liquids. Okay. Good to go. Which flow measurement method is suited for measuring low flow rates? Another very important question. Yes. Positive displacement flow measurement is best suited for low flow rate because it directly measures the volume of fluid passing through the flow. That's very, very important. Okay, good to go. Now, which flow measurement methods requires a fluid with high electrical conductivity? Yes, it's again magnetic. Okay, high electric conductivity. See, it should be in terms of microsiemens, around 1 to 5 microsiemens. At least it should have that conductivity. Otherwise, we cannot use this. Okay, right. So which measurement method is based on the principle of Doppler effect? Any guess? Yes, it's ultrasonic, based on the. So what is here? It involves measuring the frequency shift or sound waves reflected off particles into the flow stream to determine the flow rate. It involves measuring the frequency shift or sound waves reflected off particles in the flow stream to determine the flow rate. That's it. So which flow measurement is used for measuring flow rate or slurries or a non-Newtonian fluids? Any guess? Non-Newtonian fluids. Which flow measurement is better suited for the measurement of non-Newtonian fluids? So first of all, what is the non-Newtonian fluid? A non-Newtonian fluid is a homogeneous composition substance. Homogeneous composition substance that undergoes continuous deformation in the time in which a tension or a force is applied to it. Okay. So regardless, basically it's a substance that does not have its own shape. That's it. That is what the mean. It does not have a own shape. It adapts the shape of a container, the container. So now the question is, which measurement is suited for measurement of non-Newtonian fluids? Yes, again, the positive displacement flow meter is best suited for measuring the flow rate of slurries or non-Newtonian fluid because it directly measures the volume of fluid passing through the flow. Okay, good. Now, few more to add on. Which flow meter is known for its high turn-down ratio? Yes, vortex have very high turn-down ratio, meaning they can accurately measure a flow over a wide range of flow rates. Vortex, just keep it in mind. Which flow meter is based on the principle of fluid acceleration? So it's a tricky question actually. Principle of fluid acceleration. You know the answer, but it is the question is tricky. Fluid acceleration, yes. Orifice plate uses the principle of fluid acceleration to measure the flow rate of fluid, and it consists of a plate with a hole in it placed on the fluid flow, and the pressure difference across the hole is proportional to the fluid flow rate. Very simple, yes, but the question is tricky, that's it. Which flow meter is based on the principle of measuring the change in the angular velocity of a fluid? Again, a tricky question. Measuring the change in the angular velocity of a fluid. Yes. Vortex flow meter are based on the principle of measuring the change in the angular velocity of a fluid. Yes, that's it. That's it, friends. Hope you enjoyed the session. Thank you for watching. See you in the next video. Bye-bye. Take care.